Great, I think we are live now and recording. So welcome everyone for another Quantum London Stammtisch. So what it is, this is a formal conversation building on how we actually started this group. It was in a pub, but well, it was still 2019 and we were allowed to go out for a pint or two. And that's really how we kicked it off, from an idea from Paolo, trying to look at the quantum computing technologies, what this means for our businesses. There are so many groups out there which are doing a great job going into the technicalities, but we felt there was a gap into trying to understand what the business implications of these new technologies is. Hence, the group was born again in a pub, and we are now today trying to recreate that atmosphere of more informal conversation. But we soon realized there were more questions than answers. That's why we switched to also having a live event at that time, and then we moved into the webinar space. So we tend to do one webinar and then alternate with these more informal conversations. But yeah, for today, it's just building the community as much as trying to answer some of the questions we have together. So welcome to all. I see many new names today, which is great to see. So many new people, and I don't know. There's many of us, but what we normally do is we go around the table and do a very quick introduction. If everyone is okay, we can do real quick, just 30 seconds, who you are, what brings you here, what keeps you busy. So let's keep it short and nice, but it's good to go maybe around the table and do a bit of introductions. I will lead the way, I will go through the order of people I see on the screen. The first one I have is Diego Castro. Diego, if you're happy, maybe you can give us 30 seconds about yourself and introduce to the rest of the community.
Hi there. Well, my name is Diego, as you have said before. Very nice, very glad to be in here. And at the moment I'm doing customer service, and this is mostly like out of curiosity and as a hobby, and also to see if from this I can probably do a change of career. But yeah, that's mostly about me. Thank you.
Thank you very much. Next one I have on the list is Ivan. You want to tell us 30 seconds about yourself? No? Okay, let's move on then. Next one on the list is Guy Clark. Guy, are you happy to give us 30 seconds about yourself, or what brings you here? I take it as a no. People, don't be shy. This is as much as as a community, as much as is a group of people trying to understand a bit more about quantum. So please don't be shy. Next one I have is James. James, are you happy to tell us a bit more? Hey,
Hi,
hello.
Can you hear me?
Yeah, perfectly.
Yeah, so I'm just a JavaScript programmer interested in entrepreneurship and interested in quantum computing, futuristic tech stuff in general.
Great, thank you. I switched to AirPilot mode. My audio is better with the headphones. And who else we got? Next one is I have Jude on my screen. Jude, you want to give us 30 seconds about yourself?
Yeah, hello everyone. I'm Jude. I operate mostly as a data scientist, and I'm interested in all different reasons in quantum computing, the applications, the theory, everything.
Brilliant. Thank you very much. Kovila, it's your turn next.
Hello.
Kovila. Hello.
Hello. I'm Kovila. I'm a developer, and I'm just I'm interested in quantum computing, and I'm just starting to discover it.
Thank you very much. You might be in the right place. Next one I have is Maximilian. Maximilian?
Yeah, that's me. So hi, my name is Max, and I'm a first-year math student in London, and I'm just curious about computing. I have been doing quite a bit of coding before, so now I'm just interested and curious and exploring this topic here.
Thank you very much. Michael Seder.
Yes, thank you.
We can hear you.
Yeah, Michael
Hello.
Cedar. I'm
Hiya.
out of New York City. I'm an electrical engineer. I worked for IBM for many years on digital computers. For those of you, let me just give a paid political advertisement. For those of you who are interested in quantum mechanics and quantum field theory, aside from quantum computation, I would encourage you to come to our meetups. There are 2 meetups in the New York City area, the New York Quantum Theory meetup and the Brooklyn Quantum meetup. If you're interested in getting a background in the straight physics. Thank you.
Absolutely, yeah. If you want to put the links to those meetups in the chat, we are very much open community and encourage cross pollination. So feel free to include the links to the meetups in the chat. Gopal. No. Okay, let's move on. Peter Neal. I think I have you next on my list.
Yep. Hi, I'm Peter. I'm a software engineer in London. Have been for about 20 years. Was interested in quantum computing when I was a physics undergraduate a long time ago when there was no access for anyone. Now there is access. I'm very excited. Oh, and slightly worried about encryption breaking, but meh.
Yeah, as many of us, I think. Now, Zoom has decided to mix up the list, so we'll try to do my best to remember who was already told, who was not. If I don't call you, please, let me know. If I call you twice, I have a bad memory. Please let me know as well. I think we have not heard about Fred Smith. Hi, Fred. You want to give us 30 seconds about yourself? Okay, no worries. Next one. Hey, we can hear you. Hey.
Sorry,
hello.
yeah, sorry. Sorry for being
no
late.
worries.
I have my kids to prepare for exams this January, so but I'm interested in the topic and keen to learn and contribute where I can.
Fantastic, thank you so much. And Ravindra. This is now becoming harder and harder.
Hi.
I don't think I've heard from you.
Yeah, hi. This is Ravindra. Hi, everyone. I'm a senior data scientist, currently working in a big oil and gas customer. I have been following the quantum computing for almost 3 years now. Now it is I feel it's a time for building the real world, really impactful business applications. Hopefully next year we'll be there. Thank you.
Thank you. Thanks. Great. Sabarmati.
Hi, this is Virat Kothare. In fact, I by mistake logged in with my office account. So yeah, so lots of Zoom meetings, so I forgot to log out from my office account. So basically, I'm Virat Kothare. I'm from India. I am in the software field since about 18 years. Currently working on machine learning, AI, and computer vision projects. And yeah, recently I started, exploring quantum computing. I'm passionate about this technology. It is fantastic thing that I think can, change the world. So I'm quite interested.
Thank you.
Nice to meet you all people.
Our pleasure. Thank you. Sesma, Miguel Sesma.
Hi.
Hi.
I am an electronic engineer, but working as a software developer. I'm based on Madrid, and I am interested in quantum computing basically because I think it's the future for machine learning, and it's something that I haven't worked a lot with math, but I love maths. So for me, this is really interesting.
Thank you very much. Getting there, Travis, over to you for a quick introduction.
Hi, I'm Travis. I'm a PhD student at Duke University working on trapped ions, trapped ion quantum computing. Just interested to meet other people, learn more about the industry and what others are interested in. Also, I have a meetup as well, which I'll post if anybody's interested in joining.
Please do.
Travis, what would be, sorry, can I just jump in? Travis, it would be great if at some point in the next half hour, you could do a 90-second explanation of what trapped ions is and why that's interesting compared to some of the other technologies. So nothing to blow people's brains, but just a sort of executive level summary would be really interesting. Sure.
So I unfortunately do have to leave today at, well, I'm on the East Coast in the US. So at 1:30, so that's like in 16 minutes, I can happy to do that in the next 16 minutes, or I can save it for the next meetup. I just wanted to join today. And
let's come back to you when Em's finished going around the introduction. So that gives you a moment or two to prepare your thoughts. That'd be really helpful.
Yeah.
Sure.
Perfect. I think, well, I think we got everyone, right? Did I miss anyone? No? Okay.
Well, that's perfect then. So
yeah.
Travis had his 30 seconds to work out
exactly.
the summary.
Yeah, so you just want a quick rundown of what trapped ion quantum computing?
Yeah, literally the version that you would tell your great aunt rather than anything more complicated.
Sure. So yeah, so we use trapped ions, right, which are atoms with an electron stripped away. We trap those in electromagnetic fields. And then we can, I don't know if I tell my grandmother this, by the way, but anyway, and then we use the electronic structure of the ions to encode information. In order to do that, we use, we kind of fire lasers at it, right? And we excite the ions into additional energy levels. And what else can I say in 30 seconds? Yeah, and we can perform gates with those lasers. I'm happy to talk more about that in more than 30 seconds. And then you did mention something about sort of the difference. So one of the things that's really nice about trapped ions is that all the ions are created the same, right? We're actually using a natural element. In our labs, we use ytterbium or calcium, which differs than what you would see like in superconducting quantum computers where they are fabricated and there could be flaws in them. The downside of trapped ion quantum computing is our gate times are much slower. Our experimental setups at the moment are a little bit larger. But superconducting and trapped ion, and there's other obviously quantum computing technologies, but these sort of are the two that are often talked about, you know, have similar scaling issues. So there are some similarities, there are some differences, there's pros and cons of both. Sorry, anything else that I could add to that or elaborate on? I don't want to, that was my 30 seconds again.
That was perfect, thank you. I think it's one of those things that those of us who aren't coming from the technical side, if we hear 30-second summaries like that every few weeks and months, maybe in 5 years' time, we actually understand. So thank you.
Sure. Yep.
Good. So, Paulo, what do we do from here? I think you had an update from the coding community. Do you want to start with that, maybe?
Yeah. If Jude is happy to, Jude was going to give a brief update on what we've done to date and then the plans for the 4th of January.
Yeah, absolutely. So far, you know, lots of interest. We've had 2 planning sessions. Last one was really to kind of, you know, flesh things out more in terms of.
Sorry to interrupt. So, do you may want to give us 10 seconds of what you're trying to do as well? I think some people might be new; they might not be aware.
Right. Perfect. Yeah. So effectively, the history of this is. We were thinking about getting people together who are interested in learning how to code a quantum computer, but don't necessarily have a community to interact with. So, you know, no one to help them through problems or to help work through their problems as well and so forth. So the idea was, instead of having lots of people, you know, scratching their heads on trying to figure out how to do this by themselves, we could just get people into the same room or the same Zoom room at the same time. And work things out that way. So I don't know if that's clear to everyone, but that's a general idea. And then so far we've had two planning sessions, lots of interest. which is great. Last planning session was to kind of flesh things out a bit more in terms of expectations, how we go about things, people's different comfort levels. I think something around 20 people attended. And we've now got, I think, in excess of 40 people on the Slack page, some contributing with recommendations and resources. So, yeah, it's a really, really good engagement for this early on. And the upshot has been that the way we kind of intend to go about it is to, people take a chapter of the Qiskit textbook. So Qiskit is the tool that IBM provided to interact with their IBM quantum computers. People go away, have a stab at that, and then we'll get together to discuss that chapter over the hour and see whether we can add some enlightenment to ourselves.
Great, thank you. And what's next? Any plans for upcoming sessions?
Great. So yeah. So the first session is on 4th of January, 6 o'clock. Everyone is of course welcome. I think we'll probably recommend joining the Slack channel if you want to attend, because that's the best way to chat to people before we all get together, and pre-post any questions or any queries, and kind of go from there. But yeah, January the 4th, 6 o'clock is the kickoff.
And I see Paolo has put the link both for the Slack channel and event on the chat, so you can find it there. Great, thank you, Jude.
Yeah, I think it's worth saying that the Slack channel is starting to speed up. I know a lot of people who have not had to use Slack properly over the last few years, but have maybe tried a few times, have found it frustrating. Yeah, Slack is one of those things that once a group of people start using it properly, it really works. And we're just about, I think, to hit that tipping point. So I encourage people, even if they've had previously bad experiences with Slack, to join this one, and it should be useful. And then, yeah, I put the link for the Jan 4th event. So looking forward to people joining that. And yeah, thanks again, Jude, for all your work in sort of shaping this. It's fantastic.
Great. Do we want to move to the next topic on the agenda then?
Yes.
Which is
thanks, Em. So my thought, what would be good for a discussion, I haven't managed to compare the lists of who's here now and who joined the webinar last week with Professor Michele Mosca, but I'm sure there's some overlap. And I just wanted to tackle one of the problems that I can't get my head around, if anyone in this this group feels they can explain it. So, and it also links to one of the introductions that that someone made around the concern about hacking of computers through the hacking of data through using quantum computers. So essentially Michele was explaining that in time quantum computers will be able to hack many of the current, or crack many of the current encryption models. And I think, you know, we're all starting to get to the point that we can understand why that's the case. He then explained that quantum technologies can be used to protect against that. And both he and some of our previous speakers are talking about quantum key distribution. Now, what I would love the community to help me understand is what's actually going on. Is the key being protected, or is the data at rest being protected? And the reason I'm thinking about this, because obviously the angle we're trying to take here at Quantum London is, you know, more the business angles than the underlying tech angle. But, you know, we're still at the point that in order to be able to explain this to managers and executives in normal companies, we need to understand what's going on. And so, yeah, I'm trying to work out, if I'm explaining to the chief information security officer in a bank or an insurance company or a retailer why they need to worry, I'm just not quite sure what I tell him or her about whether they should be caring about things like quantum key distribution, or if that's really only for sort of very unique applications. So I don't know if anyone wants to try and unpick what I've just asked and answer some of that, or if everyone's equally confused.
Not my area of expertise. I will kind of take a stab at it. As far as the quantum cracking, it essentially amounts to things like Shor's algorithm, because a lot of quantum, a lot of encryption mechanisms are based on things like prime factoring or some other NP-complete problems, which are the kind of things that once we have error-correcting qubits, then quantum computers will be able to crack them. However, none of these things, as far as I understand it, are actually on the horizon, simply because they depend on being able to build deep circuits. So, you currently can't run a decent sized Shor's algorithm on the current hardware, right? So in some sense, nothing is at risk at the moment. As far as the quantum key distribution, my understanding there is that the main benefit of quantum key distribution is that it detects, because of the quantum no cloning theorem, it basically detects if anyone's eavesdropping. Like, no one can kind of like secretly tap your line and pull and get a copy of the key, because they'll corrupt the key in the process. And sorry, what was the third thing? There was a third thing. I guess I lost it. Anyway, so that's all from me for the moment.
Okay, so thank you for that. So let me follow up on that. So essentially, the quantum key distribution is a stopping someone taking the key when it's in transit. But ultimately, are we still encoding data in the same way in the future? Or are we actually needing to encode the data differently?
I think there is work on that, but that's outside my expertise. I think I've kind of said what I know. Anything else would be even more speculation than I already engaged in.
Thank you, Daniel. Michael, you unmuted. I don't know, was that ready to jump in, or was that by accident? No. Okay. Oh.
I'm sorry. You're talking to Michael Speeder?
Yeah,
which
sorry,
Michael are you talking
Speeder.
to?
Yeah, go for it, Michael.
Oh, what do you want me to say? I can tell some jokes. Probably heard them already. No, Daniel, who just spoke, is very knowledgeable, and I agree with everything he said. He's very knowledgeable. He comes to, by the way, the two meetups I mentioned, the two quantum physics meetups. He's a regular attendee.
Fantastic. Okay, that makes sense. Travis, you unmuted. Were you about to comment?
Yeah, I mean, I'll use the same caveat. My research isn't focused on it. I'm focused on more near-term applications and the actual physical hardware. But nonetheless, like, I mean, Daniel's right. The only thing I kind of want to add is that from everything I've read, it's sort of separated into two different areas, where one, you actually have encryption, so like breaking, RSA and things like that, Shor's algorithm is sort of targeted at. And then you have the key distribution, which it's not even necessarily preventing them from distributing the key, but it's knowing whether or not somebody actually saw the key as it was passing over a particular channel, right? And using quantum mechanics to, in essence, be able to determine whether or not the key was viewed in transit. And so it all plays into an overarching sort of security architecture, but there are some differences in those two things. Like they're kind of spread out into two different things in the literature.
What I would just say, I would just emphasize the no cloning theorem that was mentioned. That's a key theorem in quantum physics. And whereas in classical computing, you could eavesdrop along the transmission line and nobody would know, because you can make as many copies of the information as you like. You can't do that in quantum physics. If you can't make a copy. If you tried to, then the person on the receiving end would know immediately that there's an eavesdropper on the line. Yeah. If that wasn't clear.
I'm sorry, I missed who the other person that spoke was, but they said, yeah, that it doesn't stop the other person getting it. It's just it effectively, because by eavesdropping they corrupt it. It means that everybody else knows that the line was compromised. That's really the point of the quantum key distribution.
But they also could not decipher the message, because they would not have in order to send the quantum a message via the, let's say, the teleportation protocol or the superdense coding protocol, you would, the sender and the receiver need to share what's called a bell pair, which is an entangled pair of qubits. The eavesdropper would not have access to that bell pair. So whatever he intercepts, in addition to being caught for his mischief, whatever he intercepts would just be gibberish to him. There's no way for him to interpret it.
The prerequisite for that, and here I'm admitting I'm ignorant on the topic, but the prerequisite is you need to have then a quantum network, right? To allow you to distribute those messages, preventing eavesdropping. It's not just the key; it's also the mean transmission media has to be somehow quantum.
You do need a quantum network. You also need a classical net. You need a classical channel and a quantum channel.
Yeah, in fact, you can send the information via qubit quantum, or you can send the information classically over a classical line, and then decipher it. Decipher the original quantum information at the receiving end.
So, what plays to the heart of
quantum and the
then is
for the main body of the communication.
Okay, so repeat that, Daniel.
I thought it was the other way around. I thought you used the quantum channel for distributing the key, and then you use the class. You can then use the classical channel for the regular communication once you've distributed the key.
Yeah,
at least
that's true.
Again, take everything I say with a grain of salt. Not my area of expertise.
Daniel, you're absolutely correct. The encryption key is shared via a quantum link, but the actual transmission of the data can be either a quantum link or a classical link. What I would recommend to everybody is to Google or look up, however you like to do it, the teleportation protocol and superdense coding. I would also recommend Michael Nielsen's videos on quantum computing. Nielsen and his partner Chuang, Michael Nielsen and Isaac Chuang, wrote the seminal textbook in quantum information theory, which is available for free online. It's commonly known as Mike and Ike, Michael Nielsen and Isaac Chuang, the Mike and Ike book, as it's known in the field. But again, teleportation protocol and superdense coding, these are very important in quantum computation and transmission.
So then the obvious question, thank you for that, Michael. The obvious question is, if I'm the owner of a small factory with 55 members of staff and $18 million of turnover a year, I've got some computers and some data and everything. I don't understand any of this. So am I just in 10 years' time buying a quantum ready service from the same person that at the moment I just buy a normal service? Or is this stuff not relevant for inverted commas normal companies?
I think both. As in, it's not relevant right now because you can't build a decent sized short algorithm circuit. And I imagine once this becomes real, then you'll get it from third parties pretty much the way you buy your current security from third parties. I mean, let's face it, the number of people that really know how to actually implement the security from the ground up, like encryption protocols and stuff, is not that huge in the world. So at least to do it properly. I mean, there are a lot of amateurs who can do it with leaving God knows what backdoors in there, but the number of people that can do it so that no one can actually crack it is probably not that large.
By the way, you can use IBM's online quantum computer. IBM and Google are foremost in the field. That's been made public. We don't know what the Chinese government or the U.S. government or any other government is doing. I'm sure they're not going to talk about it. But you can use IBM's quantum computer. I think it's a 53-qubit computer, and you can, test your own programs. It's free of charge, available online. As far as Paolo's question about how do you something to the effect, how do you convince your non-technical savvy managers or executives about this? IBM faced the same problem 50 years ago when they first introduced the digital computation. Nobody understood it, but they realized that to get up to speed with their competitors, they would need to use it. So you don't need to know the technical aspects of it. You just need to know that there's competition out there and you're going to be left behind.
One of the big points.
Sorry. I think the thing to remember, though, is that both the IBM and the Google and the Rigetti, and those are all NISQ circuit machines. So again, you can't actually do encryption and decryption on those machines, because you can only, they're noisy, shallow. They're noisy. They've got noisy qubits, not error corrected, so you can only build the shallow circuits on them, and not enough. You don't get enough depth, or what now they call volume, to actually build an encryption or decryption algorithm that could outperform a classical one. If you're going to crack somebody's code these days, you're still better off just running it on a classical computer.
I think one of the take-home points I got from the talk, specifically to do with protecting your data and being at risk from decryption, was that most software systems are badly engineered for quickly updating their protocols, and that is probably as important in a purely classical world as it is in a quantum world. Is organizations are slow to update protocols, so if they ever get to a point where there's an arms race, that's where your problem is, because as people have said, you're going to be buying it from third parties. You're not going to be doing it yourself for the most part. So you have to engineer to be able to update quickly.
Yeah, and also, even when the quantum stuff comes, even now, I mean, it's always the human factors that are, it's probably human engineering that's actually going to be the cause of most breaches, not social engineering, not actual sort of hard cryptography that actually causes most breaches.
So what I got from Michele's talk was, for small companies, yes, they will buy it off the shelf. But if you're a big organization, some of these are structural, architectural changes, and you need to start thinking now, what's coming, who vendors should I engage? And also the other point was, we should push the vendors, we should make them aware, these are things, we care about as businesses, hence, giving them a bit of a nudge to also put these kind of technologies on their offering. That was my key takeaway from last week.
Yeah, no, that makes sense. And I think, yeah, as I made the slightly flippant comment earlier, I'm keen that we just keep on rediscussing these, because I think each time we discuss it, we become a little bit clearer. We become a little bit better at articulating, and we become a little smarter at the follow-up questions we're asking. So to the point that was made, most of this, notwithstanding Michele presenting it as if you don't start moving now, you may be in trouble, but on the whole, most people don't want to engage on this topic at the moment. So that gives us a bit of time to work out how to articulate it more clearly. What I want to do, and I've just put in the chat a link there that hopefully you can see to a website called menti.com. If people are happy to click on that, it's basically just a polling website. Then it would be good if we could actually use that to understand people's thoughts. I've got 3 sets of questions. So if people are happy to click on that, what I'm going to do is share my screen in a moment, which should allow me to then show you what's going on. Share screen. Okay, tell me if that's visible.
Not yet, but I think it's coming up. Yep, it is now.
Excellent. So have people, well, clearly people have, because we've already got 9 answers. People seem to be managing to make that link work. It's a relatively standard polling website, so it shouldn't be a challenge. So it would be interesting that the first thought is those of you who clicked other, maybe you'd like to share what other is from your point of view.
Sure. So from my point of view, again, it comes down to the fact that, you know, it's the whole NIST era thing. And my perspective is that the first areas that will be in fact impacted are areas that are driven by some form of the machine learning or data science. Those will be the first kinds of applications, simply because in some sense, a lot of the machine learning algorithms are essentially algorithms which are approximations to some kind of NP-complete or otherwise intractable problems. So on the one hand, that's where intractability becomes big. So anything that sort of is some kind of what's called satisfying or optimization kind of a problem. And secondly, in machine learning, you always have error rates and you always have noise. So the fact that we are dealing with noisy circuits, it's sort of like machine learning both needs what quantum machine has, what current quantum hardware has to offer, and then at the same time is tolerant to what the shortcomings of current quantum hardware are. So I think current quantum hardware will have the most applications for machine learning.
Got you. And so to the question of which industry may be most impacted by the ability to do that sort of machine learning, optimization, data science type problems, do you have a sense of what industry it might be?
I mean, out of those, I would guess that I suspect that the pharmaceuticals industry, to get real applications, they need something larger scale than what the current systems have to offer. I could be wrong on that. I don't really know what, I guess I don't really know the state of the art there, but my suspicion is that, you know, if you want to do some kind of like, you know, protein folding or some sort of the kind of things people do in pharmaceuticals, I suspect we're not there yet with the hardware. I suspect finance in some kind of, you know, first of all, there's money in it, so people will just throw money at it. And secondly, it may not be that complex a problem. I mean, often a lot of the financial models are not that complex. So I would guess that actually is a good bet.
Excellent. Thanks, Daniel. Someone else voted other. Do they want to?
Yeah, it is me, voted other. For me, there is a lot of focus on the environment these days. So, and people want to get away from the fossil fuels. So the alternative energy sector would be looking at the way to invent the new kind of energy sources, as well as improving the efficiency of the existing system in the battery technologies. So I think it would be the energy that will have more focus on that part, and maybe looking at the current situation.
Yeah, I like that reply, Ravinder, because I think I agree with you. I think there's an article I'll share later where Boston Consulting Group 6 months or so ago looked at this, and one of the areas, for example, they think quantum computing may help is when it comes to the generation of fertilizer, which apparently uses some ludicrously large percentage of the world's energy in a manufacturing process that most of us are completely unaware of. The other positive thing, of course, is that whenever technology is simply used to make bankers richer, the world struggles to get excited, whilst if we can say that it's part of solving the climate crisis, that's obviously fantastic PR for quantum computing. Any other thoughts from people? The graph's quite interesting there. You know, no one thinks automotive or transport and logistics. And transport and logistics, I'm surprised, because if we'd been talking a couple of years ago, sort of network optimization problems for aeroplane fleets and things was always an example that was brought out. You know, I don't know if pharma is high, because obviously that the current sort of COVID and vaccine situation means that we're thinking about that industry. Anyone want to share their thoughts on why pharma is so high?
I don't know. An uneducated guess, but purely from, you know, communication point of view, I think it will still be very high on everyone's agenda because of the contingent situation. So it's easy to bet on, oh, we'll hear a lot about, quantum computing in pharma.
Yeah. I think there's a question of between like sort of could, would, and should are sort of have different answers here. I think sort of if you think about the state of the current hardware, there's the question of like where within the next, say, 2 years will there be a real impact or a real return on the quantum compute on the efforts in quantum computing versus where maybe the effort will be made but the returns won't be realized till much later. So I imagine things like pharma, the environment, logistics, all of those things which actually require a large scale compute and large scale problems probably will not see. They may get the investment, but they may not see the returns in the short term.
Yeah, that's a very interesting point. That actually there may be some industries that are doing an awful lot on it, but in reality, the impact is still some years away. It's a very good insight. Or they might not be as good as in communicating, right? Or they might not get the airspace.
Well, I just look at the airspace. I mean, I actually hear a lot about like particularly like in pharma and biotech. I hear a lot about it, but I just find it hard to believe, given the current state of hardware, that they're actually getting the return. I think they're investing in it and exploring it, but I find it hard to believe they're getting a return on it at the moment.
Yeah, I think we're saying the same thing there. It's not what is visible is not, might not be where best results are being produced.
Well, that's why I was guessing the finance, because I can imagine fairly small models, maybe just getting the speed up. And also, yeah, people, it's not that we should or it's the most exciting. It's just that we can, and given that there's money in it, people will throw the money to get the money back, to get the short-term profit. So, it's sort of the perfect world versus the real world.
Agreed. Thank you. I've jumped to the next slide. This is just a free text slide. If people want to throw in some thoughts, it will come up on the screen anonymously. So, feel free to just sort of tap a few words or a few sentences. It'd be just interesting to see what people's view is.
Is this on the Menti thing or where? I'm not seeing anything.
Yeah, it's on the Menti thing. If you go back there, you should see I have like a small box with type in your answer.
Follow the link again. Okay, got it.
Yeah, sorry, I was on mute. Apparently you could hear me having my dinner, so apologies for that. It is on the Menti thing, and someone's clearly managed to make it work. So there we go. Here we go. Now they're starting to come through. So carry on typing, then we can have a minute or two on each. Good. So we've got one on quantum annealing in finances, more concrete use cases, and new qubit records. I guess those two are both valid and independent points. Clearly the use case are going to come from qubits, but there's absolutely no reason to think that the battle for more and cleaner qubits is not going to continue. Yeah, determine commercial viability, jobs, moving fast, starting to move into the industries we talked about, and then that AI ML point. Thoughts from anyone on this quantum computing jobs? Yeah, is this will there be people who market themselves as quantum computing experts trying to find jobs? Or will there be people in industries that need to look at this who are maybe currently data scientists or ML experts or whatever it may be, who then realize that they need to upskill to be knowledgeable? What's the sense? What's going to come first, the demand or the supply? Any views on that?
I think at the moment there are more enthusiasts doing jobs, but then again, a lot of the enthusiasts aren't necessarily formally trained. So it's going to be interesting how it goes. Although I have to say, over the last, I would say, like, I've been watching the sort of quantum job market for a while, and I would say, like, over the last month, I've seen an uptick, I think. I mean, it could be a blip, or it could be that I've been looking more, but I feel like there's an uptick. I would actually be curious if anybody feels the same.
So I think one interesting point is that there's been in the news over the last couple of months a lot of extra funding going out from governments, both in terms of government-led initiatives, but also into sponsoring, startups, quantum startups, and so forth. So, presumably, that plays a big role as a driver of what you're seeing there.
Yeah, but it seems like I've seen job adverts from like both like Zapata, Rigetti, Quantum Circuit, Cambridge Quantum, and D-Wave, and like all within like the last couple of weeks, and like I haven't seen any from them for quite a few months. I mean, prior to this.
Yeah, certainly Cambridge Quantum seems to have an incredibly long list of roles. So whether they're struggling to fill them because there aren't people with the skills, or actually whether they're filling them and just them advertising for new ones, I don't know. But it's quite impressive, the number they're looking for. You're on mute, Em.
I kind of remember from previous conversations where we discussed that there will be a lot of technical roles opening up in the short term, and then slightly longer term there will be more and more of commercial roles, salespeople, and also business translators, people being able to translate the technology to the business. I kind of remember this from previous conversation we had here.
Yeah, and it's really good actually. I think we need to find a way of tracking a little bit what the job titles we're seeing are, because obviously if Cambridge Quantum and Rigetti and people want a bunch of detailed engineer, that's not surprising. But for example, I think it was Volkswagen recently was advertising for people with certain quantum skills to go into their data team. Now that's obviously a very different requirement and quite interesting.
Michele had this role, I can't remember the exact name he used, but not the quantum architect. Can you remember what it was? The guy in your company who should care about quantum. Was it quantum architect?
Yeah, I forget now. Maybe even quantum evangelist or whatever.
Yeah.
Cool. What I wanted to do is the third and final interactive slide on Menti, and I get the sense that not all of you have managed to make it work, so apologies for that. But for those who have sussed it out, if you want to just share a word or 2 or 3 words, just to see if we can create an insightful word cloud, or if everyone just writes qubits, then it's going to be really boring, but we can see.
Now everyone is going to put qubits there.
Yeah. Cool. I'm wondering if this is working at all, given that nothing's showing up. Oh, there we go. Interface engineered. Oh, well done, Peter. Good. Word clouds only work if we have lots of words, guys. Go on. Those of you who've sussed out this highly complicated technology.
It's good to see my preoccupations getting in there early.
Yeah. Well, thank you, Peter. As people are typing, do you want to explain what you mean by engineered?
Yeah. Well, and interface as well, because they do go together. I think now that resources are available in terms of simulators and real quantum computers. The work needs to start happening about how to actually engineer with it, how to make sure that interface between your sort of classical world, where you're sometimes where you're just delivering the answers to users, how that interfaces with the quantum world that's actually going to be doing some of the work. The biggest source of bugs in software systems is across interfaces. So,
yeah,
you know,
just to recap what you're saying, essentially, this is the point that in 99.9% of all future situations, it won't be that people are doing something just on a quantum computer. They're going to be doing something that will be using the quantum computer where appropriate, and just a classical computer for the rest of the time. Yeah.
Yeah.
Yeah. Excellent. So what have we got here? Does someone want to explain quantum dot?
Yeah, can you hear me?
Yep, we can hear you, Guy.
Yeah, I've got my audio sorted out at last. The quantum dot is just the quantum technology that Intel is working on. So in that technology, instead of the IBM engineered qubits or trapped ions, it actually uses electrons as qubits, and it's quite interesting, and they've made a few big steps forward recently. And it's the kind of thing where if they can really crack it, then the technology is so similar, or the manufacturing is so similar to what they do now, that Intel might suddenly emerge as a force. They're on the periphery now, but they could become really big if they can crack that.
Got you. So essentially, they've picked a technology where, if it works, then they have a true competitive advantage, rather than simply following what some of the others have been doing a bit longer.
Yeah, they're trying to leverage their current chip manufacturing techniques.
Yeah, makes sense. Makes sense.
Yeah, I missed the introduction, but to make up for that, I'm an IBM quantum ambassador.
Ah, fantastic. So there we go. Do you want to spend 30 seconds ambassadizing at IBM?
Well, you've probably had other ambassadors on your calls before.
We had Andy Stanford Clark speak to us from the Isle of Wight a few weeks back, and he obviously did a very good job of both explaining the topic generally and, of course, talking about some of what IBM is doing excellently. So we have. I mean, what would I think be interesting, if you're happy to do it, would just be to summarize why that exists as a concept and what you actually mean by that description, if you're happy to do that.
What do you mean?
Well, what do you mean by quantum ambassador? Is that is it an outward facing role, or is it internal to help your IBM colleagues get excited about?
Well, a little bit of both. It's mainly an outward facing role, and it is, you mentioned earlier, the kind of quantum evangelist. And it's a cross between that and marketing, and it's the first step in getting companies interested in quantum. So I think it's meant to be, well, there are different types of ambassadors, and there's a level called the technical ambassador. And the idea is to ease companies in slowly, get them interested without having to go into the really technical details. And then if they're interested, then gradually ramp things up.
Got you. That makes sense. Thank you, Guy. Thank you, everyone, for inputting into this word cloud. I'm keen to try and wrap things up by the hour, as we always do. So maybe just sort of open back up to everyone. I'll stop sharing. Let me get rid of that. So if anyone sort of got any parting thoughts or questions for other people on this call as we wrap up this year and head into a slightly surreal break period?
One thing I'll drop in is people are looking for various references. So you've got like the Scott Aronson books and the Michael Nielsen books. I would also look at the stuff coming from Bob Koike and Alex Kissinger, the stuff on like the graphical calculi for sort of doing quantum calculations. I think that's a very nice sort of a way to wrap your head around some things, particularly like the demonstrations they do of like the explanation of, say, the what is it, the quantum teleportation protocol done in terms of a graphical calculus. The ZX calculus is very neat.
Okay, could you just repeat those names? Sorry, Daniel.
Oh, I don't know how you pronounce it. I've only ever seen it in Britain. C-O-E-C-K-E.
C-O-E-C-K-E.
Yes.
Okay. Okay.
Alex Kissinger, and Alex is spelled A-L-E-K-S. Alex Kissinger. Kissinger as in Henry Kissinger, double S. Yeah, and they have a tutorial book out called Picturing Quantum Processes, but they also have a series of papers on archive. So anything that you see like pictures of graphical and quantum, or things that have the title ZX in them, that's the formal name for the calculus. But it's kind of like, if you're familiar with Penrose's graphical notation for tensors, so string diagrams, it's that for quantum circuits.
Fantastic.
Yeah, I have that book. It's quite a big book. It's a long read, but it looks like it's going to be worth it.
Right.
On the subject of books and references, I'd just like to ask people what their main push into quantum education is going to be next year. I mean, personally, at the moment, I'm doing a course at Delft University on EDX. There's a couple of courses there. And also I'm looking at the MIT courses. And some of you may be familiar with those, maybe attended the webinars, got some information.
Yeah. I was fortunate enough to be able to do Peter Wittek's course before he passed away. And that was excellent, the quantum machine learning course from University of Toronto. I think you can still do it as sort of as a self-paced thing. I think the videos are all recorded, but no, like you don't get a certificate anymore, and they don't correct your, you don't get your exercises corrected anymore. I think you can still do it, but it's very unfortunate. Like he did one run of it, and then he went missing in the Himalayas later that year.
Just the MIT X Pro courses I can highly recommend. I did them all, and very interesting.
Sorry, which ones?
The MIT X Pro online courses.
X Pro. Okay, cool.
Yeah, it's like the online professional arm of MIT.
And Fred, how are they technically hard work, or will someone who's got a sort of a decent foundation be able to cope?
I think if you have a decent foundation, should be. I've got a physics background, so that obviously helped, and I have a classical computing background as well. But I've not done any of that for well over 20 years. I'm in a completely different job and just really interested in an old subject, and I was able to do it. So it should be accessible.
Excellent, thank you. Any other thoughts on that question? No. Okay, well, that's probably a good point to wrap up with. I think, we talked earlier about how we're using the Slack channel to engage people in the coding community. That's great. I'm also keen to share ideas such as these ones. So, if at any point anyone does come across a course they feel is relevant, do please share that with them and me, and we'll make sure we distribute that information to people. So thank you all for the discussion this evening. Thank you to those who've been involved in other events over the past 6 or 7 months as we moved online. Good luck for some form of enjoyable break. Now, I'm in that part of the UK where we're basically not even allowed out of our front door. So I can empathize with others who have got a bit of a messed up Christmas, but good luck with it all. Already 2 events in the calendar, as we mentioned. On the 4th of January, we'll have our coding session. And then on the Tuesday, which must be the 12th, we have got a discussion on patent protection for quantum technologies, hardware, software, algorithms, etc. It's a couple of patent attorneys. So that should be a very interesting, different angle. Look forward to you all being involved. Please keep in touch. Good evening and take care.
Thank you. Thanks, everyone.
Thank you. Goodbye.